Okay, so for question 1, I choose true because the reason why Dijkstra algorithm can get wrong with negative edge because it may skip some of the edges in the graph and just totally not like looking at it. Just like the example we went over during class. But also in Dijkstra algorithm, all outgoing edges from the start node will be looked at by it. Therefore, all of the negative nodes are guaranteed to be like went through in this case. Therefore, Dijkstra can compute a correct answer in this situation. Okay, so for question 2, there's 4 statements. The first statement is wrong because here's a counter example. Here's like definitely 2 shortest path between U and V. They have the same weight and they are both 2. And so for the second one, it is also wrong because like we can look at this graph, the shortest path tree may be like firstly S to V and to the bottom node, and then S to U, but there like actually exists one shortest path that connecting U and V, but does not in the shortest path tree. And the third one is true because from S we can reach U and V. Therefore, S is connected to U and S is also connected to V, then we can like get that U is connected to V. Okay, for the first one, I split it into 2 conditions. So the shortest path from U and V can be either contains S or doesn't contain S. So for case 1, if it contains S, then the shortest path will definitely be equal to distance to U plus distance to V. And this one is like, yeah, it fits this statement. Okay, so for case 2, if the shortest path doesn't contain S, then in order for this path to be shortest, then this path will always less than or equal to any other path connecting U and V. And then this one, distance to U plus distance to V, is definitely one of the other paths connecting U and V. Therefore, it must be greater. Therefore, this one must be like greater or equal to the shortest path between U and V. And that's perfectly satisfy the statement. Okay. So for this problem, we can see that we firstly have an outer while loop. Then in the while loop, we have one statement and one big for loop. Okay. So for the first part, like we can divide it into the while loop and this statement. That will be our case 1. And then we have a case 2 with the while loop and the for loop. Okay, so for case 1, it's just simply like big theta of V for the while loop because it's just simply go over all the vertices. And then for this one, we have removed mean of theta of n. So this one is just simply theta of V. Then we get case 1 equals to theta V squared. And then for case 2, we notice that there's an if else statement. And then here we have big theta of V, and here we just have big theta of 1. But we notice that it checked the parameter with contains method. So for this one, we like only add new nodes to the parameter like V times because we only have v vertices, we don't need to like do add for like every edges. Therefore, this statement will like only do v times. This one will result in v squared. And then for all the other like all the other lines, there are all big theta of 1. And then when we combine the while loop and the for loop, it just like go over all of the edges in this graph, so it will be resulting E. So the whole case 2 is just v squared plus E and goes to here. And then we can like just simplify it to 2v squared plus v, and we don't need the constant like in front of v squared, so we finally get big theta of v squared plus E. So for the last question, this one is like really easy. This one should choose false. Here's one counterexample. You can see that's like U is in front of V, because in topological sorting, we firstly go through A, and then U and B, and then V. Then U is definitely before V, but there is no directed graph, a directed path between U and V. Like, yeah, there's no path. Therefore, I chose false. And that's it. Thank you.